Hi everyone, welcome to the next lecture. In today's lesson, we will talk about missing data. Missing data are represented in vectors as NA. So let's go over to our studio and create a new vector called heights. We add the assignment operator with the Alt- shortcut, and in order to specify more than one element, we have to use the concatenate function. Let's add the values 2, 4, 4, NA, and 6. Please note that the NA is specified in uppercase letters. So let's press Ctrl Enter to run that command, and we can see that this vector has been added to the environment. We can now call this object to have a look at the contents. So let's type the name of the object called heights and press Ctrl Enter. We can see the values in the console. So let's see if we can now do calculations with this vector. For example, let's try to calculate the mean of heights. So you type mean, and inside the brackets you type heights. This returns the result of NA. Let's try and see if we can get the maximum value from this heights vector. So if you type max heights, it also returns NA. So most functions will return NA if your data contains even a single missing value, as I just demonstrated. In order to ignore the missing values when you do calculations, we have to add an argument na.rm equals true, which tells the function to remove the na values before doing the calculation. So let's try the mean function again. So the first argument is again the name of the vector for which we want to calculate the mean. And remember, to add another argument, we have to separate it with a comma. And then we add this argument na.rm equals, and we say true. Once again, please note that the word true is in uppercase letters. You can also just type an uppercase T, which means true as well. So I like to type out everything so that my code is readable by anyone. So we are going to calculate the mean of heights, but we will ignore or remove the NA values before doing the calculation. So let's run that. Now we get the mean value of 4. Similarly, we can now calculate the max of heights, but we add this argument na.rm equals true again, so that we ignore the NA values before doing the calculation. And now it correctly returns the result of 6. So if we want to extract the elements from this vector, but all the elements that are not NA, so any value that is not missing, if we want to extract that, there is a special function that we use for that. So once again, if we want to do subsetting or extraction, we start with the name of the vector, in this case heights, followed by square brackets. And now we use the following function, which we call is not NA. So the format of typing this is exclamation mark is.na. And once again, you will see from the suggestions, it will pop up. So I'm going to press tab to auto-complete that, and you will see that the rounded brackets are added automatically because it's a function. So the way to read it is not NA. So the exclamation means not. Alternatively, if you want to extract the missing values, you can remove the exclamation mark and it will return the is NA values. So in this case, we want the is not NA. So we want the actual values 2, 4, 4, and 6 from this vector. So inside this function, we have to specify the vector from which we want to extract the elements. So I'm going to highlight the condition inside the square brackets only and press Ctrl Enter. And you will remember from the previous lesson that our condition returns logicals. And then the logical values are evaluated, and where every position is true, the associated value will be returned. So if I now run the whole command in line 1 to 8, it will return all the values that is not NA. An alternative way to remove incomplete cases is to use the na.omit function. And once again, inside the brackets, we specify the name of the vector from which we want to extract all the values that are not missing. You will see in the console that you get 3 lines of output. The first line of output are all the cases that are not NA. So we get 2, 4, 4, 6. The second line of output is the positions of the deleted values. In this case, our missing value was in position 4. If you look at the environment, you will see that the NA was in position 4. And then the third line of output is the class of the deleted values. In this case, it says omit. Another way of extracting elements which are complete cases is to use square brackets again for subsetting. So we start with heights, followed by square brackets. And in this case, we use a function called complete.cases. And inside the brackets of this function, we need to specify the name of the vector again. So complete.cases heights will return logicals again. So let me demonstrate that again. So our condition will return logicals, which will be evaluated. And if you put that inside the square brackets, it will extract all the complete cases. This is the end of the session for missing data. And the challenge that you need to complete for the session is challenge 4. In the next session, we will start with installing and loading packages and working with data frames.